Good morning, children. Here I am with the third part of video lecture on the chapter electricity of class 10. Till this, in the second video, we have discussed about the Ohm's law and resistance, resistivity, factors on which the resistance of a conductor depends, all these things. A very important thing you must know about the circuit symbols of different electrical devices or electrical components, and for that I will forward a PDF to you, and you have to practice it, draw it again and again to practice it, okay, so that you remember the circuit components, how to draw it. Okay, now the today's topic is combination of resistors. See, resistor and resistance, people sometimes get confused in that. Resistance, actually, it is the property of a conductor to oppose the current, okay? And different conductors oppose the current in different amount. Already we have discussed that who opposes the current least are good conductors, who opposes little bit more are bad conductors, and who oppose completely, that is insulators, who don't allow the current through them at all. Now, so the property is to resist the current, that is called resistance, and the materials which offer the resistance are called resistors. So there are few devices, few alloys which are made by combining two or more metals, so that they offer more resistance, and we combine them and we make them according to our requirement. They are called resistors, and what they offer resistance. So the property is resistance, and the material is known as resistor, or the device is known as resistor. Okay, now they can be connected in two ways. The combination can be done in two ways. There is a combination which is called series combination, and second one is called parallel combination. Parallel combination. Now, what is series combination? See, resistance, actually symbol for the resistor is this one. This is the symbol for resistor. And suppose this is a resistor having a resistance R1. This is another resistor having a resistance R2. This is another resistance having a resistance R3. And they are connected end to end. Then they are said to be in series combination, when they are connected end to end. And what else will happen? You can see here, if they are connected to a cell, suppose this is positive, this is negative, okay, and a potential difference V is applied with the help of this cell. How these resistors are connected? They are connected in series. Their resistances are R1, R2, R3. There may be n number of resistors connected in series. Okay, I'm taking, for example, I'm taking only 3 here. You can take 2 also. Someone can take 100 also. No. Now, when you apply potential difference, what will happen? We know that the current will start, what will happen? Current will start from positive terminal and it will flow like this, I. Suppose the current coming from the positive terminal is I. And remember, current always starts from the positive terminal of the cell, and this is the symbol of the cell. And the symbol of battery, it is somewhat like this. It is the symbol for battery. So we can say that battery is the combination of multiple cells. Obviously, so it will offer more potential difference. So here we are talking about cell only. So due to this cell, it is offering a potential difference across these resistors, and due to that what happens, a current I starts flowing through this. Now what will happen? If current I is coming here, this current doesn't have any other path. So the same current has to flow and reach here, and the same current will flow through this resistor and having resistance R2 and will reach here, and the same current will flow through this R3 resistor and will reach here, and the same current will come and will be entering to the negative terminal. So one more thing, whatever current comes out from the positive terminal in the circuit, the same current enters in the negative terminal of the cell or the battery, whatever is connected. Okay. Now, so one thing we can say in series combination is there, that is the current flowing through all the devices is always same. If the current flowing through all the devices is same, then the combination is said to be series combination. Now the question arises, what about the potential difference? Potential difference across this is how much? I into R1 according to Ohm's law. Let the potential difference across this is V1. So, and across this let it be V2. Let it be V3 here. So what we can write? V1 is equals to I R1. V2 is equals to I R2. And V3 is equals to I and R3. Now, current is same, but what about the potential difference? Potential difference may be same, may not be same. Because see, you can see here, it depends on the resistance. If the resistance of all the resistors is same, then obviously their potential difference across them also will be same. But if the resistance of the resistors is different, then the potential difference across them will be different. Okay, they will utilize different potential difference. One more thing, the total potential difference applied is V, and this is utilizing V1 potential difference, this is utilizing V2, this is utilizing V3. So one more thing we can say, that the total potential difference V is equals to V1 plus V2 plus V3. So now we can write the definition for series combination. Please note it down. The combination of devices or resistors in which current flowing through them is same, but the potential difference across them may be different, is called series combination of devices or resistors. Okay, so this is the diagram for it, and these two things we get from there. We can write it as equation number 1, and this we can write as equation number 2. Okay, now what we can do, we want to derive an expression to find the effective resistance. Effective resistance means, so we need to find out the expression for the case of series combination. Now, for what we want to find out the expression? See, suppose instead of these 3 resistors, you want to use a single resistance, so that the whatever effect they are producing, the same effect is produced by that single resistance. Then what should be its value? So its value, whatever, what should be its value? That is the question. So we are going to find out the equivalent resistance. That means we are going to find out that value of resistance which will serve the same purpose which these 3 are serving together. So instead of 3, we want to use one resistor which can serve the same purpose, but what should be its resistance? That's what we need to find out. And how to find that? That is called equivalent resistance in series. Now, how to find that equivalent resistance in series? For that, we need a formula. And to get the formula, we will using these two equations. So, from equation 1 and equation 2, what we get? We will put the value of V1, V2, V3 in equation 2 from equation 1. So, we will get this. And we can take I common, so we will get this. And now, this is the total potential difference. Now, what we will do? Let the net resistance in the circuit be RS. Why I am writing S? Because it is series combination, that's why I am writing RS. So we have supposed that total resistance of this circuit is RS. Total potential is V. And what is total current flowing in the circuit? It is I. So according to Ohm's law, can we write an expression using this? So according to Ohm's law, what we can write? Total potential difference V is equals to net total resistance of the circuit RS into total current of the circuit I. Now let this equation number 3 and this as equation number 4. Now we can put the value of V from equation 4 in equation 3. So from equations 3 and 4, what we will get? At the place of V, we will get RS into I is equals to I into R1 plus R2 plus R3. You can see from here, this I and this I can be cancelled out. As we cancel them, we will get the required expression, and that is, okay. So from equations 3 and 4, after cancelling I, we get this. That is RS is equals to R1 plus R2 plus R3. That means if in a circuit 3 resistors are connected, this is suppose of 5 ohm, this is of 10 ohm, and this is of 8 ohm. And suppose you want to replace them with a single resistor. So what should be its resistance, or what should be its equivalent resistance? Sometimes we write this RS, that is equivalent to R equivalent. So what should be the value of the resistance which we can connect instead of these three? A single resistance. What should be its value? So for that, what we need to do, we have to find the equivalent, that is series equivalent. So that is RS is equals to, this is R1, R2 plus R3. This is R1, this is R2, and this is R3. So we can simply add them 5 plus 10 and plus 8. So what we will get? 10 plus 13, that is 23 ohm. So we require a resistance of 23 ohm to replace these 3 resistors. And this is the equivalent resistance for this circuit. So in this way we can calculate the equivalent resistance of any circuit when the resistors are connected in series. This is the formula for that. Simply we have to add the resistors. So it's very easy. And now we have to go to the parallel combination. The next one. Okay. Now we are going to study about the parallel combination. What is parallel combination? Maybe of resistors, maybe of some other devices, bulbs, okay, maybe fan, maybe something else, okay. So what is parallel combination? When we say that it is parallel combination, see, suppose we are taking the help of a bulb here. This is the bulb, suppose one bulb. This is the second bulb. This is the third bulb. And all are connected in like this. positive, this is negative, current will flow like this. So current will start from here. If the potential difference applied is V, it is a battery, not a cell, and their resistance is R1, R2, R3. Current I will reach here, and after reaching here, it will have two paths, 1, 2. So what it will do? It will get divided. Suppose here current I3 goes. The remaining current will pass through here. That is I minus I3. Because I3 has gone there, so total was I, so I minus I3, that is remaining will go through this. And then suppose I2 enters here in this bulb. As I2 enters here, the remaining current will be I minus I minus I2 minus I3, and let it be I1. So I1 reaches here, and from here we'll get I1, from here we'll get I2, from here we'll get I3. So here will be, it is I1 plus I2, and then again I3 will get added up, and we will get I1 plus I2 plus I3, and that is equals to I. So the current entering the negative terminal will be I. So what we find? We find that the current, same current is not reaching to the different devices or different bulbs or different resistors. Current reaching to different devices is different. So it is not the same case, similar case. In series combination, the current reaching to each device was same, but here it is maybe different. I'm not saying that strictly it will be different, because again, if the resistance of the devices is same, then the same current will be reaching to them. Okay, now what about the potential difference? Potential difference, what is found? Potential difference across this, let it be V1, across this let it be V2, across this let it be V3. So what we can write? V1 is I1 R1, V2 is I2 R2, and V3 is I3 R3. Now, current is also different, resistance is also different, but remember one thing. If suppose this device is removed, this is directly connected to these two, so these two will be glowing, no problem at all. If these two bulbs are removed, then also it is connected to third one, no problem, it will glow. So this battery is directly providing the same potential difference to all the three bulbs. So potential difference across all the bulbs is same. That is not V1, V2, V3, but that is only V, that is applied potential difference. So in parallel combination, what is same? The potential difference across all the devices is same, and that may be equal to the applied potential difference across them. So write the definition. The combination of devices or resistors in which the potential difference across each device is same, but the current flowing through them may be different, is called parallel combination of resistors. Now, we need to find out the equivalent resistance in case of parallel combination. So for that, this is the circuit diagram. You can see three resistors are there having resistances R1, R2 and R3. They are connected in parallel. This is with the cell, and a current I is flowing and reaching at this junction. When it reaches at this junction, then the current gets three different paths. So I1 current flows through R1 resistor, I2 current flows through I1 current flows through R1 resistor, I2 current flows through R2 resistor, and I3 current flows through R3 resistor. And finally they combine and become I and reach to the negative terminal of the cell. The potential difference across this cell or offered by this cell is V, and According to definition of parallel combination, we know that potential difference across each resistor is going to be the same, that is equal to the applied potential difference. So here, can we write from this diagram this equation, that is I is equals to I1 plus I2 plus I3. Can we write this? Because these all three have come from I only, and they are again combining to give I. So we can write this expression. This is equation number 1. Now, using Ohm's law, for all three resistors, what will we get? For first one, potential difference will be V because all are in parallel. Current flowing through it is I1, resistance is R1. So can we write V is equals to I1 R1? And from here, can we get this? I1 is equals to V by R1. Similarly, for the second resistor, can we write V is equals to I2 R2? And what will we get? We will get I2 is equals to V by R2. For third one, we can write V is equals to I3 R3, and that will give us I3 is equals to V upon R3. And this is our equation number 2. So here is our equation number 1, here is our equation number 2. Now, from equations 1 and 2, from equations 1 and 2, what we have to do? We have to place these values of I1, I2, I3 in equation 1. And let's see what we are going to get. Okay. After putting the values from equation 2 in equation 1, we will get this one. And we can take V common, we will get this one. And let us mark this equation number 3. Now, let the equivalent resistance of the parallel combination. That means, let the resistance of that single resistor which can serve the purpose of all three together be Rp. Why I am calling Rp? Because it is a parallel combination. You can write R equivalent also. So let the net resistance of the combination B Rp, or you can write R equivalent also. So when you are taking total resistance, net resistance of the circuit as Rp, total potential difference is how much? V. Total current in the circuit is how much? I. So according to Ohm's law, can we write V is equals to I Rp, and from here we need value of I. You can see from equation 3. So can we find value of I from here? I will be how much? V upon Rp, and this is our equation number 4. So we got this value of I. We have got equation number 3. From 3 and 4 we have to write the expression. So from equations 3 and 4, we have to put the value of I from 4 in 3. Okay. So after putting the value from equation 4 in equation 3, we get this. And now, if we take this V this side, this V will get divided to the side, and we will get V upon V Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. And this V will cancel out. So 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the expression to find the equivalent resistance. If there are only 2 resistors in the circuit, then what will happen? What we will get? I can show you here. 1 by Rp is equals to 1 by R1 plus 1 by R2. So 1 by Rp will be how much? You can take the LCM and add them. So simply you can write R1 R2 and you can get R2 plus R1. And but you have to find out Rp. So Rp is equals to, you have to invert both sides. So R1 R2 by R1 plus R2. After inverting, you will get the result. Here, most of the people make the mistake. They don't invert it and they write, oh, this is the result only. So if the numerical question is given, you are supposed to put the values and then take the LCM, and then after getting result, you have to revert it. If you're not reverting, then you will get the wrong answer. Now, suppose there are n number of resistors connected in parallel, then 1 by Rp is equals to 1 by R1 plus 1 by R2 plus dot 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 plus 1 by Rn. In this way you have to proceed. So this is the expression for resistors connected in parallel. This way you can use it. Okay, now we have to, okay, let us take up this question about parallel combination. There are three resistors, 9 ohm, 18 ohm, 36 ohm, and they are connected in parallel with a battery of 6 volt. What we need to find out? We need to find out the equivalent resistance. As they are in parallel, so we have to find out Rp, or you can say R equivalent. That's what we need to find out. So first of all, we have to write the formula. That is R1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now see, we are going to put the values. Let this be R1, this is R2, this is R3. So what we'll get, 1 by Rp is equals to 1 by 9 plus 1 by 18 plus 1 by 36. Now LCM will be, straight away you can say, it will be 36. So 9 4 ja 36. So 4, 18 2 ja 36. 36 1 ja 36. So what we will get? 4 plus 2, 6 and 1, 7. So you will get 7 by 36. This is equals to 1 by Rp. Don't forget this is equals to 1 by Rp. Now what will be Rp? You have to invert it. So Rp will be equal to 36 by 7 ohm. And this is how much? 7, 5 yeah 35. 1 is left, place decimal, it will become 10. 7 1 is 7. 10 minus 7 is 3. You get 0, 30. 7 4 is 28. 2 is left. Again 20. 7 2 is 14. And then we can write ohm. So it is coming around 5.142 ohm. So in this way we can calculate the equivalent resistance in case of parallel combination. One more thing we can say. In series you have seen that we used to add the resistors. So we can use the series combination where we are having the resistors of smaller resistance, but we require in a circuit to connect a resistance of higher value. So we can add them together, we can connect them together, and we will get the higher value of resistance. Suppose in a circuit you want a resistance of 10 ohm, but you are having only 5 ohm resistors. So simply you can connect two 5 ohm resistors in series. 5 ohm, 5 ohm to get a 10 ohm. Okay. So series combination increases the resistance. Now what about the parallel combination? You can see from here. We have got, in parallel combination, we have got 5.142 ohm. But what was the resistance of different resistors connected in parallel? It was 9 ohm, 18 ohm, 36 ohm. So it is less than all of them. Even it is less than the least of them also. That is 9 ohm. It is less than 9 ohm. See? So that means parallel combination reduces the value of resistance. So suppose you are having all the 5 ohm resistors, or and you require, suppose you require out of that you require very less resistance, or you are having all 10 ohm resistors. Suppose you have got 8 ohm resistors. So 3 8 ohm resistors. 3 8 ohm resistors are there, okay, and you require 2 ohm. So how will you do? If you connect two two 8 ohm resistors in parallel. So what will happen? Let's see what will happen. Suppose you are connecting two 8 ohm resistors. See, so it will 1 by Rp will be how much? 1 by 8 plus 1 by 8. What you will get? 2 by 8, and that is 1 by 4. So 1 by Rp is how much? 1 by 4. But Rp is how much? It is 4 ohm. Just as it has become half. So if you can connect, if you take one more combination like this, 8 ohm and again 8 ohm. So again this will give you 4 ohm. So this 4 ohm, this 4 ohm, you can connect in series. So how much you will get? 8. But if you want 2, then what you have to do? You have to connect them in parallel. If you connect it in parallel, so this is going to give you how much? 4 ohm. This will give you 4 ohm. This will also give you 4 ohm. Already we have calculated. And these two 4 ohms are in parallel. So what will happen? When they are in parallel, so you can write 1 by Rp, again you have to apply 1 by 4 plus 1 by 4. That is how much? 2 by 4. So cancel out 2 1 ja 2, 2 2 ja 4. So 1 by Rp is 1 by 2. So Rp is how much? Rp is 2 ohm. And that is your required resistance. So although you had all the only 8 ohm resistors, but out of that you can get 2 ohm by combining them in this way, that is in parallel combination. So the parallel combination reduces the value of resistance, and series combination increases the value of resistance. Okay. We will discuss some more properties of series and parallel combination. Okay. Here you can see the three LED bulbs are connected with a battery of a 4.5 volt in series. And here 3 LEDs are connected with a 4.5 volt bulb, 4.5 volt battery in parallel. Now what will happen? See, suppose okay, current is flowing and all three are glowing. Current will be same, but their resistances are different, so they will get different potential difference. And when they are getting different potential difference, what will happen? This will glow more brighter, this will glow less brighter, and this may glow even less brighter. Now what will happen? Suppose this bulb gets fused. What will happen? The circuit is discontinued. When circuit is discontinued, we call it open circuit. Open circuit. When circuit is open, then no current will flow through the circuit. And when no current will flow through the circuit, then what will happen? The current will not reach to these two bulbs, and so they will not glow at all. But what about in parallel combination? See, this current is reaching from here and it is reaching to this junction, and then it gets divided to all three parts. So what will happen? All are glowing properly. But suppose this bulb gets fused, what will happen? Obviously, current will not able to pass through this. This part is detached. But what about these two? Current is reaching like this, it will pass like this and reach here. For this also it will reach like this and will pass and will reach here. So for this two, the circuit is still closed, even though this bulb B1 has got fused. So for this, circuit is open, but for these two, circuit is still closed, so they will glow. But what about the series combination? If one is blown off, others are not going to glow. And that's why we prefer parallel combination in the household circuits, in the schools, in the offices, everywhere. And that's why you find, if one device is blown off, it is not necessary that only bulb. It can be any device, fan, refrigerator, AC, anything. Then other devices don't stop working because it's parallel combination, so all other are getting the potential difference to work because of parallel combination. But if you are going to connect them in series, if one is blown off, all will be switched off. So that is the advantage of using parallel combination in the household circuits. One more thing, already we have discussed about the potential difference in current, but for measuring potential difference, a device is used that is called for potential difference. A device is used that is called voltmeter. Voltmeter, which we denote by V like this. Actually, this voltmeter is a high resistance device and it measures the potential difference between 2 points across a device. It may be, if it is a bulb, suppose this is a bulb and you want to measure the potential difference across this, so you have to connect it like this in parallel. Only then it will be able to measure the potential difference across this. Okay. Here also, if you want to measure the potential difference across this bulb, you have to connect it like this. That means it is always connected in parallel. Now the question arises, why it is connected in parallel? Because it is a high resistance device. So if it is a high resistance device, then what will happen? If we connect in series, very nice. If we connect in series, as its resistance is very high, so it will, resistance of the circuit will increase, because in series resistance increases. So its resistance will get added up to all the other resistances in the circuit, and so the resistance of the net resistance of the circuit will go very high, and when the resistance goes high, then the current in the circuit will reduced, and so the other devices connected in the circuit will not work properly. And that's why we always connect voltmeter in parallel, because it is a high resistance device. If we are talking about the ideal voltmeter, so it is told that ideal voltmeters have infinite resistance. That means if an ideal voltmeter is connected in series, then no current will flow through the circuit, because it has infinite resistance. So it will completely stop the current. Now, there is another device which is used for measuring current, electric current, and that is called ammeter, which we represent by letter A. This is a low resistance device. Low resistance device. So as it is a low resistance device, can we connect in parallel? Let's see. Suppose we are connecting this ammeter in parallel. What will happen? Okay, current will start from here, I, and that will reach here. Okay, when it reaches here, then what will happen? It will reach here like this. Now when current reaches here, it has got two paths. Obviously bulb has got higher resistance, the filament is high resistance, that's why it glows. And ammeter is a low resistance device. So current will follow which path? Higher resistance or lower resistance? If you are told to go to your school from home, and there are two ways are there. One is a very nice smooth road, another is not good road, but actually what you will find, lots of pits are there in the road, okay, and it's very rough one, okay, and lots of ups and downs are there, and lots of crowd is also there, okay. So which one you will like? Obviously the smooth one. So here the current prefers to go through the device which has got lower resistance. So maximum current will flow through the ammeter, and so the current will not flow through the bulb, and so bulb will not glow. Very small current will flow through the bulb, so bulb will not glow, because it will not get the required amount of current. So that's why we cannot connect the ammeter in parallel. So ammeter is a low resistance device and it is connected in series like this. It is connected in series. And when it is connected in series, obviously it is low resistance device. It doesn't affects the resistance of the circuit a lot. It affects, but very, very less. It is negligible, okay, because it is a very, very low resistance device. And so the current continues to flow properly through the circuit, and it measures the current in the circuit. Now, if we are talking about the ideal ammeter, then ideal ammeter has zero resistance, and that is ideal thing. You know, ideal things practically do not exist, okay. Okay. Now, do all the devices have resistance? Always? No. There are temperature for different materials at which their resistance almost becomes zero. And then those substances are called superconductors. Like, for example, mercury. Mercury, when it is reduced to 4.2 Kelvin temperature. Now, Kelvin scale is a different scale. Like, see, you know the in Celsius scale, no? In Celsius scale, 0 degree Celsius is equivalent to 273 Kelvin in Kelvin scale. And if I am talking about 0 Kelvin, then it is equals to minus 273 degrees Celsius. If I am talking about 4.5 Kelvin, then just reduce this 4 point from here. So what you will get? 3. That is 69, 68. 268.5 minus degrees Celsius. At this temperature, the resistance of mercury becomes almost zero, and so starts behaving as a superconductor. And these superconductors are used to make the supermagnets in laboratories for different application. Now, the lowest temperature achieved till date is how much? 0 Kelvin, that is minus 273 degrees Celsius. And that's all for today. Thank you.